Our first rock, which you probably heard of, is called obsidian. It forms when magma or lava comes out of the ground and cools down so quickly that there's not time for crystals to form. So the composition consists of no minerals, but just whatever elements and compounds just got vomited out of the earth. It has no mineral crystals. It's a type of glass. It's extremely sharp. Tuff is when you have layers of volcanic ash and debris that get crushed into a rock and become very strong. Well, not super strong, but kind of strong. It is a slang word, unfortunately. Pumice is when you have lava with a ton of air in it that explodes out of the ground and forms bubbles and cools very quickly, and it's very buoyant and sometimes floats on water. Can form these rafts from underwater volcanic eruptions that disrupt shipping and fishing. Rhyolite is essentially a very fast-forming version of granite. It has a lot of silica in its composition, and it has a very smooth texture because there isn't time for large crystals to form, like in granite. This texture is called aphanitic, which means it has small crystals, but not that many big ones. It's sometimes found in volcanoes, but that's rare. Andesite is essentially a more silica-poor version of rhyolite. It's similar in composition to diorite. It's sort of intermediate between felsic and mafic. Basalt is basically all of the ocean floor is made of basalt. Basalt is relatively dense, about 3 grams per centimeter cube. It forms fast, and it has a lot less silica in it than granite, but rich in magnesium and iron. Forms in island arcs, hotspot volcanism, and sometimes flood eruptions that can sometimes kill most of life on Earth. Granite is a low-density rock with large crystals and a lot of silica. It cools slowly. It forms the underlying bedrock of most of the continental crust. It's also found in magma chambers, mountain ranges. It's very strong. It can also be found in really old rocks. And it's sometimes even radioactive due to trace uranium. Diorite is a more silica-poor version of granite, but it's not actually that silica-poor. Diorite, which in Minecraft people often refer to as bird poop, is a silica-poor version of granite, but it's not that silica-poor. It's intermediate. I don't know why I'm looking at the sun for some reason. Gabbro is basically basalt, but it cools very slowly and has large crystals. It's found on the ocean floor sometimes, but rarely. It's also found in greenstone belts and other formations. Peridotite is a relatively dense green rock at about 3.3 to 3.5 grams per centimeter cube. It makes up most of the upper mantle, and when the upper mantle gets exhumed to the surface, you can see it. It can sometimes have rare gemstones in it. It's green because it has a lot of olivine in it. Now we have sandstone, which is made of relatively large gritty particles, also known as sand, that have been crushed together into layers sometimes, but also sometimes just a large rock mass. You can find it in ancient deserts, ancient sea areas, like coastal areas. There's a lot of places where you can find it. Okay, mudstone. This is when mud, a lot of organic matter and random minerals dry out and get baked into a single rock. This is claystone. Forms from clay, obviously, which is like a specific size of clay mineral flakes and other things. Then we have siltstone, which is formed from extremely small particles that are crushed together in like rivers and things. And shale, I believe, is the most common sedimentary rock. It's formed of flakes of clay minerals, has oil in it sometimes, and often mud. Glacial till conglomerates, or tillite, are formed when glaciers scrape rock. Alluvial conglomerates are formed in like river deltas in lakes and oceans. Fluvial are formed in the river itself. Deep water conglomerates are formed in deep oceans and lakes, and shallow ones are obviously formed in shallow oceans or lakes. Over here, limestone. Sea creatures have calcium carbonate shells and they get crushed together, but it can also come from other sources. It's grainy and formed in shallow water. Ironstone is essentially any sedimentary rock with quite a bit of iron in it. Chert is iron poor, and sometimes you find it between ironstone and banded iron formations. It's made of very specific type of silica called cryptocrystalline silica. Cryptocrystalline means the particles are so small you can't see them. Microscopic diatoms in the ocean produce these tiny pieces of silica. Phosphorite is basically any sedimentary rock with a lot of phosphorus in it. Brown coal, it's low grade, it hasn't undergone metamorphosis yet. Chalk is basically the deep water version of limestone, so there's little disturbance when it is formed, and it's like not, like its structure is not disrupted. Precipitous rock is chemical precipitated minerals that build up. Evaporites is when you have mineral-rich solution that evaporates. Banded iron formations are basically when you have oxygen that fills up a body of water with iron dissolved into it, and the iron precipitates out as it rusts, and it comes out in these layers. So here we have graphite, which is just coal that's been crushed so much that it only has carbon in it. This is high-grade anthracite coal that has been crushed a lot, so it's metamorphic. This is felsic plutonic gneiss. You find it in like old geologic shields. It's when you crush granite or some other felsic rock a ton and it gets twisted. Migmatite is a metamorphic rock that's been crushed so much that it partially melts and then solidifies. This is serpentinite, which is a very water-rich metamorphic rock that comes from basalt and other mafic volcanic rocks. And it has a lot of water. It forms under high pressure but low temperature. You find it in subduction zones sometimes. Metaconglomerate is basically one of those conglomerate gravel-made rocks that's been crushed so much it metamorphoses into different minerals. This is green schist. It's another basaltic sort of metamorphic rock that you find in greenstone belts. This is metapelite. It's a clay-made metamorphic rock. It formed when clay is under a ton of pressure. This is slate. It's a low-grade metamorphic phase of shale. It still has the same layers. This is phyllite, which is slightly higher grade. Schist is flaky and even higher, and gneiss is the highest grade. Quartzite is made when sandstone or other silica-rich rocks are crushed in so much pressure that they form that. Hornfels is when magma bakes surrounding rock under low pressure, causing it to partially melt. And marble is just very crushed chalk or limestone. Amphibolite is basically the basalt version of granite gneiss. It's extremely blue sometimes, has a twisted structure. Granulite is formed under high pressure, and it can be formed from like any plutonic rock. Eclogite is basalt that's been crushed so much that it's actually denser than the upper mantle, and it's why oceanic plates can sink at subduction zones. Blue schist comes from something mafic, meaning silica poor, which is like basalt or gabbro or something, that's been crushed under very high pressures but relatively low temperatures, which is rare.